This example involves trying to determine how much power is required to perform a certain amount of work in a certain amount of time. So we know the displacement of the box, we know the applied force, so that's the force of push that we have on the box, and we know the time. We know that power is equal to work divided by the time because it's the rate at which work is performed. So looking at the formula, we don't know the work, so we're also going to have to figure out the work, which is just equal to force times displacement in order to figure out the power. So that's our first step. Since we know the force is 20 newtons, we know the displacement is 100 meters, we can figure out the amount of work that's done just by multiplying those together. So we have 20 times 100, so that's going to be 2,000 joules of work. Then the next step is just to figure out the amount of power. So for the amount of power here, we just take that amount of work that we just found, so 2,000 joules, and we divide that by the time, which is 18 seconds. So if we take 2,000 divided by 18, we get 111.111 watts of power. So that's how much power is required. So conceptually, the other thing that I would make sure that you understand is what would change the amount of power that's required. What could make this value go up? What could make this value go down? So what would you need to change in anything here in order to get this value to either go up or down? So I'm not going to answer that right now because that's an activity we're going to do in class, but it's something I want you to think about